So for tonight's lesson, we're going to use the foldable that you made in class today. So hopefully you have this there. It's 4 little pages. You should have conditional statement, converse, inverse, and contrapositive written on there. Now, a conditional statement. Okay, this is the first kind we're going to work with. A conditional statement is just an if and then statement. Now, you don't need to write this yet because you're not going to know how long to make the blanks here, but a conditional statement is an if and then statement. So you can think about things like, if you study for your test, then you will do well on your test. That's a conditional statement. If you go outside in the rain without an umbrella, then you will get wet. So it's kind of like a cause and effect. It's a, if this happens, then this happens. So we're going to use a really common one. If a shape is a square, now you should start writing, then it has 4 sides. So when you see this statement, if a shape is a square, then it has 4 sides. That's a pretty safe thing to say, right? So the part here about a shape being a square, that's kind of like our cause, and the has 4 sides is one of the effects of something being a square. So the word we're going to use to describe this part of our if-then statement. So the if part is called the hypothesis. Okay? It's not a hypotenuse, it's a hypothesis. Now the then part, or the effect kind of part of our statement, is called the conclusion. So we have a hypothesis, and the result is this conclusion. So if a shape is a square, then it has 4 sides. You could also come up with other conclusions. You could say if a shape is a square, then it has 4 right angles, or then it looks like a box, or then it is not a circle. So anything that you put here would be a conclusion. But it's important that you understand which one is the hypothesis and which one is the conclusion, because the rest of these statements are all going to be built just based off of the fact that this is the hypothesis and this is the conclusion. You're going to have to do something that you do very well when you watch a movie. You're going to have to kind of suspend your reality or suspend your belief. It doesn't really matter what the words say in any of these statements we're going to do. All that matters is which one is which, hypothesis or conclusion, and where it actually goes in the statement. So another way that you're going to see hypothesis notated in this class is going to be with the lowercase letter p. And the conclusion you're going to see with a lowercase letter q. And a lot of times you're going to see this written, if p, then q. Because once you identify the hypothesis as p and the conclusion as q, well, you can rewrite this a lot faster than you can rewrite this sentence over and over. Okay, another way that we can write this, or p, then q. And hopefully you remember last week or so when we talked about this arrow notation. This means a lot of things in math class. Okay, last lesson we had this pop up. It meant that a triangle is mapped onto another triangle. And here it means that if p, then q, or p, I'm going to write under here, implies q. All it means is that if this happens, then this happens next. Now, if you think about this conditional statement here, if a shape is a square, then it has 4 sides. Hopefully you can think about a Venn diagram kind of scenario. I know you remember Venn diagrams are the things with the big ovals. So the big oval here would be the 4 sides, right? There's all kinds of things that have 4 sides. Now, if a shape is a square, then it's going to be in the 4-sided shape family. We'll kind of put this up here for you to look at and get an idea about it. So here is my Venn diagram. Okay, of course I got my Q just a little bit not where I want it, so I'll move it over there. All right. So if a shape has four sides, or I'm sorry, if a shape is a square, then it has four sides. Now, you want to think about your specific conditional statement. So, if a shape is a square, so we have a shape that is located here in this hypothesis circle. This is where the hypothesis is. This is the square. Is it also going to be in the four-side circle? And the answer to that is yes, definitely. It's definitely going to be in there. So this conditional statement right here is true. I want to take just a minute to tell you, when we make these things like this foldable paper, the goal is not for you to be creative with it and make it your own and write things in all kinds of goofy positions. The goal is for you to kind of duplicate what we're doing here. So when I write this word true way down at the bottom here, you want to also put the word true down there. Okay, right in line with conditional statement. So this conditional statement is true. Now we're going to flip to the next page. Okay, so go ahead, flip your book. And we're going to talk about a converse. Now, a converse is also an if and then statement. But if you'll notice, I have blue and red, or before I had red and blue. So a converse is when you switch the hypothesis and the conclusion. So I'm not going to continue to write the words hypothesis and conclusion. What I'm going to write, as you probably figured out, I'm going to write that this is Q, that was my conclusion, and this is P. So the converse of a statement just means that we take the hypothesis and the conclusion and we switch them. So this says if Q then P, or Q implies P. So if a shape has four sides, so now that's the conditional part, that's the little part, right? So I got this shape, and it definitely has four sides. Then it is a square. So you want to ask yourself, and you want to be drawing this, pause as you need to, but you want to ask yourself on this statement, if a shape has four sides, so it's right here in the four side region, does that mean that it absolutely must be within this square region? Or is there a possibility, could it be like this? Aren't there four-sided shapes that are not squares? Hopefully you're saying yes, there are. So our conditional statement, or our converse statement, our converse statement says that if it has four sides, then it is definitely a square. Is that true or false? Now, hopefully you will see that is false. I'm going to write that down there on the bottom, okay? So all of this, try to keep this moved up a little bit. I should have moved it up a little higher, I'm sorry. All right, so all of this goes down there. This false goes down there on the converse line. So that's a converse. I'm going to move on to the inverse. Again, the inverse is an if and then statement, and you'll notice here that the red and blue are switched back where they were. But an inverse, which you probably figured from math, you know what an inverse is. It's kind of like the opposite, or something different about it. So the inverse of a conditional statement is going to be, in math terms, it's going to be the negative version, or we'll say the negation. So this is negative P and negative Q. And the way that we negate these statements is we say that if a shape is not a square, then it does not have four sides. So just a little bit different. Okay, we're taking our hypothesis and our conclusion, leaving them where they were, but we're making them not whatever they were. So if it was a square, now it's not a square. If it did have 4 sides, now it does not have 4 sides. And we can write that out. Oops. We can write that out by saying negative P implies negative Q. Okay, so that just says if it's not a shape, or shape's not a square, then it doesn't have 4 sides. So we're going to take a look at what that would look like. Now, our hypothesis, our little part, our conditional part, is the P. Our conclusion is the Q. But what this specific statement says is that if we have a shape, now it's not a square, so it's not going to be inside this red oval. It's going to have to be outside of it. So if it cannot be a square, does that mean it also does not have 4 sides? Or are there actually shapes that are not squares, but they do still have 4 sides? Hopefully you're thinking of a rectangle. That would be our counterexample to this statement. So this picture is what the statement says. It says if it's not a square, then it does not have 4 sides. And hopefully you'll see that that is false. It's a false statement. Okay, now the last one is the contrapositive. Okay, the contrapositive, once again, it's an if and then statement. And you'll see that my blue and my red are switched again. So now I'm going to have my P and my Q flip-flopped. But I'm also going to negate them. So I'm going to have negative Q and negative P. All right, so my statement would say if a shape does not have 4 sides, then it is not a square. So I could write negative Q implies negative P. So that when I read that, I see this and it says, okay, so it's not 4 sides, not a square. Okay, I'm good with that. Let's see what that Venn diagram looks like. So our hypothesis, our Q, that's our kind of conditional part. That's the part that we really we really care about. Then I put my kind of conclusion, my effect. All right, so this says that if a shape does not have 4 sides, so it's definitely not going to be in the 4-side region. So this is not a 4-sided shape. Then it's also not going to be a square. So that means it's going to live, its little dot that represents it is going to be way out here. So a shape does not have 4 sides, then it's also not a square. Now is that true? Or could I have something that's not 4-sided, so that means it has 5 sides, but it is still a square? And the answer to that is definitely no. So this statement that this contrapositive describes is true. Okay, so when you close your book all back up, it should look like this. Now, the reason we did that, that's a very important reason, is for you to recognize that the converse and the inverse have a very special relationship. They are known to be, or called, I don't know the right word to say this, but they're logically equivalent. And the conditional statement and the contrapositive are logically equivalent. What that means is if the conditional statement is true, then the contrapositive is always true. That is such an important thing for you to memorize. Hopefully you'll take me seriously when I tell you that. The converse and the inverse, if the converse is false, then the inverse is false, logically equivalent. Now, sometimes all four will be true, and we'll see that happen here in a couple of days. But for now, focus on this. If the converse is false, the inverse is false. If the conditional statement is true, the contrapositive is always true, regardless of what the words say. All right, so we'll see you tomorrow.